Today we are going to look at section 7.1, the law of sines. Oops. We're going to use the law of sines to solve, if possible, the triangle or triangles in the ambiguous case. We're going to find area of an oblique triangle using the sine function, and then we're going to start solving applied problems using the law of sines. Okay, now that we know how to use the law of sines, this process can help us when asked to find problems involving figures like the one below. Notice that in this problem, there are technically three triangles, two of which are right triangles. Triangle CDA is a right triangle and CDB. Triangle ABC in this picture is an oblique triangle. But if they're asking for us to find H, in both of those right triangles, we wouldn't have enough information using SOHCAHTOA to find that right away. So what we're going to do is we're actually going to need to think about this oblique triangle in order to help us get to more information for the right triangles. So notice that the oblique triangle ABC, that side of AB is a length of 238 and angle A is 25. Technically, we only have two things in that oblique triangle, so we wouldn't be able to do the law of sines. But because they gave us this 29-degree angle, hopefully you notice that angle B, so ABD, is a straight angle, and that's 180 degrees. And so this angle right here, ABC, we actually know that measure because it's a part of a straight angle and the other angle right next to it is 29. What we have is supplementary angles. If I take 180 and I subtract 29 from it, we have the measure of angle B. So that's a 151-degree angle right there. And so then notice that in that triangle ABC, we actually have an angle side angle situation. So we are able to use the law of sines. So what we can do is we can figure out technically any piece of that oblique triangle. I'm going to say let's find this side A, which is across from angle A, because then that is also a part of the right triangle CDB, and that's going to help us get closer to finding H. Okay, so if I want to find A, notice that we can take that A and put it over the sine of angle A, which is 25 degrees. That would have to be set equal to the only side we know is this 238-degree length, or side length. Notice that that is actually technically across from angle C. So we have to do one more step. We have to figure out what angle C is. But now that we know that angle A is 25 and angle B is 151, once again, three angles of a triangle add to 180. So if we subtract 151 and 25 away, we have a 4-degree angle. So that would be over the sine of 4 degrees. So then we can find the length of A by doing our cross multiplication. So we'll have A times the sine of 4 degrees equaling 238 times the sine of 25 degrees. We can divide both sides by the sine of 4 degrees. And so that gets us our A by itself. At the very end, it's asking for us to round to the nearest tenth, but I don't quite want to round to that nearest tenth right now. I'm going to go out just a few more decimals just so I can have a pretty accurate answer. So right now, this is approximately, let's say, 1,441 point, let's just do 3 decimals. So that would be 918. Once I have that, now notice that if I focus on the triangle of CDB, notice that in that right triangle, we have this 29-degree angle. What we found was technically the hypotenuse of that right angle, and we are trying to figure out what that height is. So now we can just go back to what we had done previously in other chapters. We can start thinking about SOHCAHTOA because we have that right triangle. We can finish solving. So notice that I am wanting to find the opposite. We're given the hypotenuse, so we are once again using sine. So the sine of 29 degrees has to equal then h over this 1,441.918. So I'm going to get rid of that denominator by multiplying both sides by that number. That gets rid of it here on the left. And then now I can go ahead and I can round my final answer in the calculator to the nearest tenth, like the directions are asking. So because the calculator says 699.0557, I'm going to look at that second decimal, which is a 5. That is going to round that first decimal from 0 to a 1. And so that would get me my answer. But it took us doing the law of sines first in order to then get to our SOHCAHTOA type situation. Okay, so let's talk about the third way to use the law of sines. It's something called the ambiguous case. So it's with two sides and an angle not included. So if we are given two sides and an angle opposite one of them, does this determine a unique triangle? Such a case is called the ambiguous case because the given information may result in one triangle, two triangles, or no triangles at all. So we are going to look at the different situations. Consider a triangle in which side A and B and an angle A are given. This information may result in one triangle. That's because A is greater than H, which is representing the height of that triangle, and A is greater than B. One triangle is formed with that information. When A equals H, so the side opposite angle A is representing that height, and it's just the right length to form a right triangle. So once again, we still just have one triangle. If A is less than H, so it doesn't match the height, it is not long enough to form a triangle, so that's the situation when no triangle exists. If A is greater than H and A is less than B, two distinct triangles are formed. So that's in this picture right here. Okay. So let's figure out. We're going to solve the triangle ABC. If angle A is 57 degrees, A is 33, and B is 26. We are going to round lengths of sides to the nearest tenth and angle measures to the nearest degree. Okay, so once again, we don't technically know if we have no triangle, one triangle, or two, but I'm just going to start off by sketching one triangle just so we can see. Here's ABC. Notice the situation. They gave me angle A to be 57. They gave me side A. Can't really see that that's a 57. Side A is 33, so it's across from it. And then the side B is 26. So notice that we have two sides and an angle not included. So that's why this is forming our ambiguous case. Okay, so we are using the law of sines. We are given enough information for one nice fraction. We have the side of 33, that is A, and we have angle A. So that's going to be over the sine of 57 degrees. So notice that we know what the side of B is. So that means that we need the sine of angle B down in the bottom. We are now going to cross multiply like we have every other time. But this time, notice that we are solving for an angle and not a side. So we want to figure out what the measure of angle B is. So when we cross multiply, 33 times the sine of angle B equals 26 times the sine of 57 degrees. In order to find angle B, we are going to divide by 33 to get that sine of B by itself. So now because I want to find the measure of an angle, remember, to find a measure of an angle in your calculator, this is when we are doing the inverse. So we are going to do inverse sine, and then we have to do 26 times the sine of 57 degrees, and then we'll have to divide by 33. So that's how we want to type that into the calculator. So second sine, 26 times the sine of 57. Make sure you close the parenthesis for that angle of 57. Divide by 33, and it gives us the measure. So it gave us the measure of angle B, because that's what we were finding, to be, and since it says round to the nearest degree, it was 41.358, so it turns into a 41 degree angle. Okay, so because we were able to get the measure of that angle, we are going to have at least one triangle. So now we want to determine if we are going to have a second triangle. So we are going to use that angle B that we just found to try to determine if we are going to have a second triangle. Remember, angles of a triangle have to add up to 180. So what I'm going to do first is I'm going to find the supplement of this angle. So to determine if we have a second triangle, I'm going to do 180 minus 41, and that gives me 139 degrees. So that is potentially the other measure for angle B. Other measure. Okay, but the original angle that was given to us was a 57 degree angle. So let's think about this. If we think the other angle B is 139, if I take 139 and I add 57 onto it, I still have to be able to add one more angle to have the three angles add to 180. But notice that if I add these two numbers up, I am going to get an answer that is bigger than 180. This ends up being 196. So there's no way I can take that angle, add one more angle, which has to be a positive number, and have it equal 180. This situation doesn't exist. And so because I was not able to get that angle to add up with my original angle and be less than 180, we do not have a second triangle. Okay, so no second triangle exists. So I can just go back to my 41 degree angle. That is the only measure for angle B. Now that we have that, I have two more things left to find. I have to find the measure of angle C, because we were only given the measure of angle A, and then I also have to find the side of C. The information from that one triangle is going to be our final answer. So because we have the measure of angle A to be 57 and angle B to be 41, to find the measure of angle C, remember I'm taking 180 minus 57 minus 41. So that is going to give us a measure of 82 degrees. To find our measure for C, we're going to do the law of sines. So we are going to use the information that we began with, which was the side of 33 and the angle to be this 57 degrees. So 33 over the sine of 57 degrees. This is going to equal. Now I want to find the measure of C, or the length of C. I'm given that angle C is 82 degrees. So we are now going to cross multiply. That gives us then 33 times the sine of 82 degrees to equal C times the sine of 57 degrees. We'll divide both sides by the sine of 57. And once again, we are wanting to round to the nearest tenth for sides. So because we have a 38.965, We are going to take that second decimal of 6. We have to round up the 9. That would round that up to a 10, which takes the 38 and rounds that up to a 9. So 39.0 would be that length. And so then once again, this is everything because we only had one triangle. And so we're done. So now let's solve the triangle ABC. So once again, I just want to do a quick sketch, even though I don't know the situation. ABC, so I can kind of determine. Notice that A is 50. Side A is 10. Side B is 20. Okay, so notice that we have two sides and an angle. That's why this is the ambiguous case. So we need to use the law of sines. Notice that we have everything for A's. So we're going to do 10 over the sine of 50 is going to equal, and then the only other side we have is 20. So that means that once again, we are putting it over the sine of B, and we want to solve for B. So we are going to cross multiply. We have 10 times the sine of B equals 20 times the sine of 50 degrees. We want to get the measure of angle B, so we are going to divide both sides by 10. And once again, we want to find the measure of an angle. So that means in our calculator, we need to do the inverse button. So we'll do 20 times the sine of 50, and then we'll divide it by 10. So inverse sine, 20 times the sine of 50, close that parenthesis to stop that angle, and then we'll divide by 10. In your calculator, if you are doing it right away, you're going to see something that says domain error, okay? If you get that in your calculator, that does not mean that you made a mistake necessarily. Obviously, you might want to go back and double check that you did type it in exactly how it should be written down on your paper. But if you continue to get that, that is okay. That's because if I didn't actually put all of that into the calculator, if I just did 20 times the sine of 50 and divided it by 10, so prior to this step here, if I still had the sine of angle B equals, but then I did 20 times the sine of 50 divided by 10, you would get approximately this angle, this length of 1.5321. So if I'm trying to find the measure of an angle, notice that what I have is something that is bigger than 1. Remember, in a unit circle, the unit circle has a radius of 1. And because this number here is something bigger than 1, that's why it's not possible to find. We cannot have that decimal be bigger than 1. So that's why it didn't work. And so that's why there's nothing for us to solve. There is no triangle. So there's no missing pieces for us to calculate. So if you ever get domain error, like I said, double check that you did put everything into the calculator correctly. But if you did and you continue to get that, no triangle. All right, let's look at this one. We want to solve triangle ABC. So once again, I'm just going to kind of sketch what could be the triangle ABC. We know angle A is 35 degrees, side A is 12, and side B is 16. So notice that we have two sides and an angle not included. So that's why this is going to be the ambiguous case. So we will start with 12 and divide it by the sine of 35 degrees. That's going to equal, we have the side of 16, and we'll divide that by the sine of B. So we once again are going to cross multiply. So we can start solving for angle B. So we will have 12 times the sine of B equals 16 times the sine of 35 degrees. We want to get that sine of b by itself, so we will divide by 12. To find the measure of the angle, we are going to do the inverse in our calculator. So we'll do 16 times the sine of 35 degrees, and then we'll divide that by 12. When we do that, notice that we don't get domain error, so that means that we have the measure for angle B, rounding to the nearest degree. Because it's 49.8, we round that up, so 49 rounds up to 50. So we know we're going to have at least one triangle. But remember, for us to determine if we have a second triangle, I want to take that measure. So now I want to see what the other angle B measure could potentially be. So we take 180, we subtract 50 from it. That gives us 130 degrees. Notice that with my original angle being 35 degrees, the question is, can I take 130 plus 35 plus something else and have that equal 180, which is how the angles have to add up to? Well, notice that these add up to 165, which is smaller than 180. So that means that that checks out. And so we have two triangles in this situation. We have a triangle where angle B could be 50 degrees, but we also have it where angle B could be 130 degrees. So that means that not only do we have two triangles, we have to find the measure of angle B, the measure of angle C, and the side of C twice. So we just found the measure of angle B. Now we need to find the measure of angle C for both triangles. So in the first triangle, when angle B was 50, we can do 180 minus 50 minus 35. That gives us a value of 95 degrees. If we want to find the measure of angle C in the second triangle, we already kind of have that situation. That blank that I have is that third missing angle. So I have to subtract 165 from 180, and notice that that angle C is a 15-degree angle. The last thing I have to do for both of these triangles is find what the side of C is. So I'm going to find in the first triangle the side of C. I go back to the original fraction. I want 12 over the sine of 35 degrees. If I want to find side C, notice my first triangle, angle C is a 95-degree angle. Okay, so I'm going to cross multiply and then start solving for C. So hopefully maybe at this point you're a little bit quicker and you can kind of see how that's going to be set up. So 12 gets multiplied by the sine of 95 degrees, and because C got multiplied by the sine of 35, essentially we end up having to divide by that. When I plug this into the calculator, we will get, rounding to the nearest tenth, we have 20.8. So there's all my information for the first triangle. So now I just have one more thing to do. I have to find the side length of C for the second triangle. So once again, I'm going to use my 12 over the sine of 35 degrees. This equals, now to find side C, we are using angle C from the second triangle, which is a 15-degree angle. So if we cross multiply here, and we think about how that product ends up being, to get C by itself, we want to take 12 times the sine of 15 degrees, and we'll end up having to divide by 35 degrees. We'll round to the nearest tenth, because the calculator says 5.41, it'll become 5.4. So notice that this is my information for triangle 1. And then over here, this was my information for triangle 2. So we have two different sets of answers. Moving on, area of an oblique triangle. The area of a triangle is equal to 1/2 the product of the base times the height. Hopefully that's something that you remember from geometry. Yesterday, using the right triangle trig, remember we showed that one of the situations was that the height, h, equals b times the sine of a. That's if we focused on angle A. So therefore, the area equals 1/2 times b times c times the sine of A. Okay? So also, area is going to equal 1/2 a times b times the sine of angle C, or area equals 1/2 a times c times the sine of angle B. So notice there's 3 different situations here because you have 3 different sets of sides, 3 different sets of angles. But if you notice the pattern here, 2 sides that you pick, you need that third angle that is not across from either of them. But it's always 1/2 the base times the height. But this time, because it's an oblique triangle, we're multiplying by the sine of A. That's representing the height. Okay, so we want to find the area of a triangle with 2 sides measuring 8 and 12 and an included angle of 135. So think about if I randomly labeled it ABC. If I named one side 8, one side 12, the included angle is always the angle that is in between them. So that would be angle A here. So notice that the angle that I'm giving you is across from the unknown side, and that's how it always should be. So if I want to find the area, once again, we want to do 1/2, and then because we have everything set up how we need it to be, we have the 2 sides and the angle that is included. We're just going to take the 2 sides and multiply them together, and then multiply that by the sine of our angle, 135 degrees. Notice that the directions are asking for us to round to the nearest square meter. So when we do that, oh, that should be a 12, not a 2. In our calculator, we get 33.9411, so on. So to the nearest square meter means to the nearest whole number. So 33.9 means that we want it to be 34, and then square meters, we got to put that unit with it. But that would be the area. So it's the 2 sides and the angle that is included. All right, so let's talk about some applications of the law of sines. We've seen how trig of right triangles can be used to solve many different kinds of applied problems. The law of sines enables us to work with triangles that are not right triangles. As a result, this law can be used to solve many problems involving surveying, engineering, astronomy, navigation, and the environment. All right, so let's look at some problems with bearings. This should remind us of what we did in previous chapters. So sketching a picture is going to help us out here. It says 2 fire lookout stations are 13 miles apart, with station B directly east of station A. So once again, think about your compass. You got your north, your south, your east, and your west. So it's saying that one station is east of the other. So here's one station, here's another station. So station B is east of A, so that means it has to be to the right. So A is going to be here, B is going to be there, and they are 13 miles apart. Both stations spot a fire. The bearing of the fire from station A is north 35 degrees east. So if you remember the bearing, we are always wanting that angle to be formed with the north-south line. Because it's specifically talking about station A, that's where I want to be thinking about my origin of my map. So northeast means I want to go up and to the right. So here, say this is where my fire is. If you remember, like I just said, the angle is always formed with the north-south line. So that means 35 degrees is right here. Then it says the bearing from station B is north 49 degrees west. So bearing from station B, I want to think about B being the origin. Northwest means we're up and to the left, which makes sense. That's how we get to the fire. Notice how 49 has to be that angle formed with the north-south line. So if it's asking how far to the nearest tenth of a mile is the fire from station B, notice that to find that, we are actually trying to find that side across from angle A. So we want side A. In this problem, I have one side given in the triangle, and notice that I have no angles inside the triangle. But because I have that 35-degree angle, I technically know what angle A of that triangle is because those two are complementary. If I subtract 90 minus 35, that gets me my angle. So this is a 55-degree angle. Same idea over here. That 49-degree angle is complementary to the angle that's inside the triangle. So 49 taken away from 90 gives us a 41-degree angle. So notice that we have an side angle situation. And so that means that we now have everything that we need to do the law of sines. So because I want to find side A, I want A to be over the sine of the angle across from it. So that's the 55-degree angle. That equals, notice that the only length we have is 13. Notice that the angle across from it is the angle that we don't have. But 3 angles of a triangle add to 180. So if we subtract 55 and 41 from 180, that will get us our angle that we need for this problem. That is an 84-degree angle. So we are going to divide by the sine of 84 degrees. So now we can start solving for A. We are going to cross multiply. Once we find A, we have found our answer. So remember, if I think about the cross multiplying, our sine of 55 degrees is multiplied by 13. We'll end up having to divide by the sine of 84 degrees. And so if we put it in and then we round to the nearest tenth, notice we have 10.701, or sorry, 0. So that 0, that's the second digit, tells me the 7 is going to stay as it is. So my missing side is a length of 10.7 miles. So that would be my answer. Okay, so that's us using the law of sines to solve, if possible, the triangle or triangles of the ambiguous case. We talked about area of an oblique triangle, and we did some application problems.